Hello all, welcome to today's video, and today we'll be discussing about message queues. Therefore, basically, before discussing about message queue, I would like to touch upon few points why we want a message queue or what problem essentially that message queue is trying to solve. So that we will discuss it, and then we will go for trying to understand what is message queue. Therefore, let's take a scenario where there are two processes in an application or kind of a simple application where there are two processes, process A and process B. Let's assume process A produces some items. Let's call those items as messages. And process B consumes those items or consumes those messages and processes those messages or act upon those messages. Then essentially process A needs to communicate to process B to transfer the messages which are produced in process A and transfer it to process B. Therefore, this inter-process communication can happen reliably, or we can that particular framework is already there. So what is the limitations of that particular framework? Therefore, assume a scenario where process A produces items at rate R1 and process B consumes those items or consumes those messages at rate R2. So if R1 is the rate at which the process A produces the messages and R2 is the rate at which process B consumes the messages, if R1 is equal to R2, then there is no such issue. Means process A can directly communicate to process B, and process B can act upon those messages and send the acknowledgement back to process A, and process A can continue producing the other messages. Therefore, the limitation comes when the rate at which the process A produces the message doesn't is far greater than the rate at which the process B is able to consume that message, or there is a discrepancy between the rates R1 and R2. Then in that situation, what happens is that application will encounter a huge delay or huge lag in performance because process A would not be able to run at its maximum rate, say R1, because A has to wait for that particular process B, wait for the process B to consume the message which is sent by process A. Therefore, the process rate at which the process A would be working would be far less than R1 in that scenario. So in those situations, message queue comes to the rescue. So let's understand what essentially is a message queue. Message queue is essentially an asynchronous queuing framework. By asynchronous means that the process A, which is called a producer, doesn't need to bother about who is consuming the messages or who is consuming the messages which is produced by process A, and process A can work independently of process B in our example. For process A can continue producing at rate R1. It doesn't matter whether process B rate of production R2 is equal to R1 or R2 equal to R1. It can very well go ahead and process the message at its own rate, say R2. Therefore, that is what is called as asynchronous queuing framework, where each process doesn't need to depend upon each other. Or in a for scenario, in a process A doesn't know about the existence of process B. That is the perfect decoupling that we can achieve between the two processes. And next, it is typically implemented as a standalone process or a service. This messaging queue will be a standalone process in itself, or it will be actually implemented as a Windows service, running as a Windows service. Like in our Windows, there is a messaging framework called Windows Messaging Queue or MSMQ, we call it. So apart from that, there are many other open source. There are some third-party messaging frameworks available called RabbitMQ, ZeroMQ, etc. Therefore, it is typically implemented, it will be a standalone process in itself, or it will be implemented as a service. Therefore, we have already discussed this thing. Means items which are stored in the queue are generally called messages, and each message is processed only once. This is the important aspect to remember. Therefore, once the producer produces a message M1 and pushes into the queue, and that if any of the consumer consumes that message M1, it is vanished from the queue, and no other consumer would be able to access the message M1 or receive message M1. That is the main point to remember about message queues. Going forward for the applications of message queue, it is typically used in microservices or serverless architecture, where different process, as we can discuss, as we have already discussed, individual processes, if it needs to communicate with other processes, then typically we use this messaging queue framework, that event driven framework, for the communication. And there are two entities which are, actually, there are three entities, but basically, there are two actors which are involved. One actor is called producer, and the other actor is called consumer. And in between that, message queue comes. Producer is an entity which produces messages and adds it to the pushes it to the queue, infuse it into the queue. And consumer is an entity which consumes messages from the queue, and once the message is consumed by the consumer, it will be deleted from the queue and no other consumer would be able to access the message. That is the that is the important point to remember about this message queues. And coming to a simple animation of this particular message queue, how it works, the left hand side is actually a producer which produces different messages. In this case, we have MSG1 and MSG2 are two different messages which are produced by a producer, and there are two consumers which is listening, which is continuously polling into the message queue for checking for any new messages. Therefore, what happens once a producer produces a message one? Let's see. Once producer produces message one, it pushes into the message queue, and whichever consumer is able to access the queue first, be able to retrieve the message. It is not mandatory that message one will be consumed by consumer one. It can also be consumed by consumer two. But in that case, consumer one, the other consumer will not be able to access the message. So in this case, the consumer one got a hold of message one and is able to process message one. And let's see the path of message 2. Message 2, once it is produced, it gets pushed to the message queue, and this message 2 is consumed by consumer 2. So that's how the flow goes. This is essentially a uh, basic animation of that message queue. There can be multiple producer and consumers to the message queue. Essentially, the pops up pattern that we know is naturally an extension of this message queue in itself. There also we will use message queue where each also is a natural extension to this particular message queue, where that each there will be different subscribers to a particular topic, and that particular topic would be in the form of a queue, and each producer will be producing to a particular topic or essentially to a queue, and there will be different subscribers to a particular queue. And once the producer produces that particular message, all the subscribers receive that same message. So that's the basic difference between the pub sub pattern and this message queue. Okay. We'll be discussing about this PubSub pattern in the coming video in more detail and with animation and all. Yeah, that's it for today's video. And if you like the video, do subscribe the channel and do press on the like button and do share your thoughts in the comment section. And if you like the video, do share with your colleagues and friends. Yeah, that's it for today's video. Thanks.